Well, good morning. I'm really excited to be here too. My name is Richard Campbell. I'm from Vancouver, British Columbia, which looks an awful lot like this. You know, we're kind of mountains and trees and ocean, and it only rained twice last week, once for 3 days and once for 4. So I have my Gore-Tex jacket with me because, I know better. That it all seems very familiar, actually. At Rich Campbell, sort of my social media is everywhere. So I'm not that hard to find, and I'm happy to talk with any of you about these subjects and many others. I'm not new to artificial intelligence topics. The weird story for me is that back in 2016, I was actually doing some work for the Vatican, and we were doing a business accelerator for a group of companies that had strong social goals. And the now past Pope Francis had supported that and encouraged us to do the 16-week accelerator in Rome in July, which I do not recommend. And in the middle of it, I had a request by a group of the cardinals to say, could you talk to us a little bit about artificial intelligence? Now, I'd been adjacent to the ML space, and a lot of things have been going on. And this is only 2016, so this is before all the crazy had started. So I put together the original version of this talk, which I called The Perils and Promises of Artificial Intelligence, and wanted to set folks a little bit of grounding about where we were going with no idea of what was to come at the time. So I've changed the title for a reason. I've changed it to After the AI Hype, because that's where we are. So let's start at the beginning. The most important thing, which is to recognize that the term artificial intelligence is actually a marketing term. It was created by a couple of scientists. I picked Marvin Minsky, but there's a couple others who blame this. Back in the 1950s, before the transistor, before digital computers, we were still in electromechanical computers, there was this belief that we had enough computing power that we could simulate human-like behavior for certain kinds of work. And so Minsky and a bunch of others put together this proposal for the US military to say, we can use computers to automate a bunch of workflows here, but we're going to call it artificial intelligence because you'll give us more money. Now, they succeeded and actually built a lot of the automation engines that the US military still depends on, primarily for what they call force projection. The ability of the US to move troops and equipment to any part in the world is unmeasured by anyone else. And that's a lot of the technology they built at the time. But the money sort of dried up after that. They call it an AI winter, which is to say they're not being paid anymore. So they move on to the next thing. But the area stayed active, and there was a bunch of other experiments going on. And Joseph Weizenbaum, in the early 60s, with the beginning of mainframe computers, actually wrote a piece of software called ELIZA. He didn't mean it as a joke. He meant it more as an example of how easily humans are confused by software. This was they called a Rogerian therapist, where it would ask, how are you feeling? Or what's your problem? And then it would respond to you with some fairly, based on the words you gave it, it would speak those words back to you, very Rogerian. And again, he meant it as a demonstration of we can simulate intelligence with software fairly well, where there's no intelligence at all. And yet people spent hours with this thing, which seems familiar. Humans have evolved competitive advantages to perceive intelligence in other things. It made us good hunters. If you could think how the mammoth was thinking, so that you could fool it into doing something that would put it at a disadvantage so that you could feed your family. It was a powerful effect, right? We call it anthropomorphization. There's also another word, pareidolia. Pareidolia is the tendency for humans to see faces in other things. Now, this is a weird trait because we see faces in all kinds of things. But if you think about in a pre-technological society, when you're on the savannah, the one that sees the eyes of the predator first and gets running first probably lives. And if they're wrong, they just get laughed at, but they still live. And so this instinct to see faces in things repeats over and over again, even in the things that we make or the pictures we find on Mars. Turned out not a face, just a hill. But we put them in our cars, and then we give our cars names. But they're machines. So we have this tendency. Now, the term artificial intelligence may have been coined in 1955, but most of the public never heard that term. It was purely in scientific circles. The rest of us heard the term artificial intelligence in a movie in 2001: A Space Odyssey. Stanley Kubrick's masterwork. He wanted to make a serious science fiction film. He was up against Flash Gordon. And he went to Arthur C. Clarke and said, can you help me write a really great script for a serious story? And at the time, Clarke had a couple of short stories, which he eventually started into this larger movie that then later became the book. And in the movie, if you haven't seen it, I do recommend it. It's extremely long. And there's no word spoken for the first 25 minutes. Both the beginning and the end of this movie are odd. But in between is quite a remarkable science fiction adventure. And one of the most important characters is an artificial intelligent computer named Hal. And then Hal tries to kill everybody, sort of setting us up for this weird relationship we have with the term. And it's a recurring theme. 20 years later, we get Terminator. And 20 years after that, we get Ultron, over and over again. In science fiction, we have this term used. So it's not a surprise that we're a bit confused by it. Nobody seems to ask, what's artificial intelligence? Because everybody thinks they've seen the movie. And I have to ask them, so when you say artificial intelligence, what do you mean? Now, there's been a number of iterations after the 50s into robotics and different kinds of learning systems. But the current wave that we're in right now has been going on for about 15 years. And it starts with this fellow, Geoffrey Hinton. Originally English, got his degree in artificial intelligence in the 1970s. Moved to Canada, was working in the University of Toronto, did a lot of early work in neural nets. And the neural net was only one strategy that they fit underneath the artificial intelligence umbrella, alongside decision trees and other strategies. But in the 80s, the computing power was pretty restricted, and we couldn't do very deep neural nets. Hinton wrote this paper in 86 on backpropagation, where he talked about deep neural nets, many layers. Now, this is just a visualization. These are not neurons, even if you call them that. These are literally memory locations with reference tables against them and weights and values that can be computed backwards and forwards. So given a set of inputs, you can get to a set of outputs. That paper in the 80s, he largely said, hey, this is a scalar compute problem that overwhelms the computers we have at the time, so it's really not worthwhile. But fast forward to the 2010s, and a bunch of his students, including folks like Ilya Sutskever, dust off that old paper and think, hey, can we build a deep neural net with backpropagation and start to see some real computing potential about it? And they enter a competition called the ImageNet competition. Now, ImageNet had been going on for a few years, and what it was a data set for doing image recognition. It's funny today, we take for granted that our phones are perfectly capable of identifying what's in any photo. But 15 years ago, that was impossible. All right? There was XKCD cartoons about how impossible it was. What ImageNet actually was 14 million marked images. So they had identified what was in each one of these images, and your challenge was to have a piece of software that could look at each image and recreate the caption. And the first couple of years that it ran, people were scoring under 30%, maybe 40%. But those graduate students working under Hinton built one of the first deep convoluted neural nets anywhere in 2012, and their first run in 2012, 84%. And the next year, 100. And this story was over. Right? We had image recognition and it worked, and the neural net had a grounding that was sufficiently precise. Now, I don't want to say this is the only neural nets that we're building at the time, because it's simply not true. This was almost an emergent time. Right in parallel, there were other groups. That's East Coast. On the West Coast, and Stanford Research Group, they were also developing neural nets, but they were focused on language. We'd already had language systems for years at that point, but you had to train them. So if you wanted to actually speak to your computer, you would practice certain sentences into it until it got better, it responded to your voice. But those folks at SRI, they'd used a neural net to train on lots of different accents and produce an initial product that Apple bought, to Siri. And now you didn't have to train it anymore. It just knew all those different voices, except Australians. Insufficient data set. So 2013, things are getting a little crazy for the folks at U of T. That's Sutskever in the background, Hinton in the foreground. And Google encourages them to form a company to commercialize the technology that they built. And as soon as that company is formed, they buy it. and them, and ship them all down to the Silicon Valley to work at Google. That group they were going to is a group called Google Brain, which had been formed in 2011 to sort of consolidate a lot of AI thinking that was going on at the time amongst all these different technologies. And this freaked a bunch of people out. Google had been doing a good job of recruiting most of the best minds in this space. And if you remember back that far, in the 2013-2014 timeframe, there were a bunch of luminaries, let's call them that said, we're concerned about the direction that AI is going and that we want this to happen more in the open. This was folks like Bill Gates and Elon Musk and the late, great Stephen Hawking. What they were concerned about was this group, the Google Brain. They didn't say the name out loud, but that's actually what they were talking about. And then a group of those tech billionaires, including Reid Hoffman and Musk and Thiel and Sam Altman, formed another company, a company called OpenAI, with the specific job to recruit those scientists out of Google Brain, which they succeeded in doing. It's just that they didn't fund it the way they said they were going to fund it. You know, even recently, Elon was saying, I put $100 million into OpenAI. It's simply not true. It was $16 million and 8 Teslas. He also tried to take the company over a couple of years in and got kicked out of the company entirely, which is why he's still scrumpy with Sam Altman. They were so underfunded that they were really limited in the work they could actually do. And their initial project was a universal translator. So they'd come up with a very clever strategy to decompose language into tokens, into numeric symbols that work better inside of a neural net, but were also relatively language agnostic. So you could feed those tokens in from one language and have them spit back out in another language. Right? This was the preformed transformers. That was the idea originally. But they also found that the more language they trained it on, the better it was at responding to the sentences you were feeding it. The first version we saw in public was called GPT-2, and they made a bunch of different versions of it with different parameter sets, mostly because they were broke. They couldn't afford to run their largest model themselves, so they had smaller models to save money. And you could try different versions of this. It was open source, although they were getting concerned with what people were doing with it already. Now we're at 2019, and that was about the time that Microsoft showed up. Kevin Scott, who at this time now works at Microsoft in the office of the CTO, previously the CTO at LinkedIn, which Microsoft had acquired, he had a good relationship with the folks down in the valley, and so he knew a lot of the OpenAI folks and knew how strapped they were for cash. And he looked at what was happening with GPT-2 and thought it was pretty cool, and he wrote a now famous letter to Satya where he said, I have an idea. Let's kick these guys $1 billion and move them on to Azure. Now, because his actual mission was to get more workloads for Azure. Microsoft was all in on being the cloud, being the central focus, and so find workloads for Azure. And this is a really clever deal. We'll invest in the company, and then they'll give us all the money back in the form of Azure consumption, which is what we wanted anyway. And they went for it. $1 billion is a lot of money, and they burned through it fairly quickly, and then there would be another $2 billion following it. But in the midst of that, as they now had enough money and they were leveraging Azure hard to start building larger models, they produced a paper called the Neural Scaling Laws. And this paper in 2020 is kind of an anchoring moment for a lot of the crazy that is to come. See, machine learning had some very fundamental rules that it followed. And one was that you have a training set and you have your operating set. And you don't train too hard on the training set, or it will only be good at the training set. It won't be good at anything else. That you train up to a 90 percentile accuracy, but if you try and train any higher than that, it actually falls off as soon as it goes to other data sets. This paper completely contradicted that position. What it said is, the more we train in language, the better we'll get with language. What we need is more of everything, which is another good way of saying, give us more money. And the tech companies responded. So then one of the guys on that paper was Dario Amodei. This is now the CEO of Anthropic. This is a fairly small group of people that have led most of this. 20, 30 folks ultimately responsible for driving most of what's going on here. GPT-3 comes out in May of 2020. So this is what they spent the $1 billion on, was to get to this 175 billion parameter model generated inside of Azure. Microsoft actually did a bunch of press release things around that time on it, they called it the 5th largest supercomputer in the world. They'd harnessed multiple Azure data centers to actually render the model down. It was only so good, it still didn't understand a lot of things, but it was enough that the GitHub folks grabbed onto it and said, what if we gave it a more restricted set, not just language in general on the internet, but specifically coding languages? So GitHub Copilot comes first. And it's a great name, which means Microsoft didn't think of it. Because the implication was ideal. It's a Copilot. That means you're still the pilot. It's your fault. But the early versions, GPT-3 was only so robust. And the OpenAI guys saw this, and one of the things they realized was we're having too much similar response sets coming back. Because we've trained on such a large set of data, the probabilities are consistently all in the 60%. So there's like 4 or 5 responses to any given sentence that rank roughly the same. And yet, to us, they're not the same. So they started a second-order training set. That second-order training set was now, we'll get back to a set of responses, we'll have a person rank those responses and send them back in. And gradually we'll build up this training set that helps to tune the first order set. Cost them a lot of money. They did it in the least expensive places they could, places like the Philippines and Indonesia, having people review the data sets over and over and over and over again. And they got another $2 billion from Microsoft. And they ran out of money by the fall of 22. Fall of 22, they couldn't afford to keep doing this. So they thought, what we'll do? Let's let the public train it for us. That's ChatGPT. So in November of 22, ChatGPT comes out. And if you remember the first versions of this, it always spat back 4 answers because it was still basically the model they were using for the training system. And then your communication back with it would actually help for it to assign higher preferences for any given response. It changed over time fairly quickly. But the bigger thing that happened was that 100 million people signed up for it in 2 months. So by January of 23, there's a bit of a crisis going on. System was never meant to scale that big, and it was running on Azure. So a whole lot of Microsoft people didn't have a Christmas because they kept the system up as the number of users just went through the roof. I had an opportunity to talk to a couple of the folks that I knew inside of that group and said, why do you think 100 million people signed up in 2 months? He says, I think it's because we did it over Christmas, and people would rather talk to software than their families. Get a dog. Talk to the dog. Nope, everybody's talking to software. But that 100 million mark is a trigger in the tech industry. You're considered a viable product when you get to that. That's why we have this ranking system. How long did it take you to 100 million users before you considered viable? How many months did that take? And 2 months was extraordinary. Nothing had ever come that quickly before. Gartner has this concept called the hype cycle, and the hype cycle starts with a technology trigger. The technology trigger was ChatGPT, that 100 million users in 2 months. Now, if you map this to the dot-com boom, the dot-com boom wasn't started by the internet being available to the public. It was the IPO of Netscape going through the roof. That was the trigger for the dot-com boom. So we're into the crazy, right? And fortunately, if you've been in this industry a while, you recognize a hype bubble when it starts. And so off it went, too much money, too many companies, wild speculation. Microsoft's out the gate first because they were there first. It was the first time that Satya Nadella wrote a letter to the whole company saying, hey, this was in January of 23, every team has to study the OpenAI APIs and implement them somewhere inside of their app. Make a Copilot. Apparently there's hundreds of them. Hopefully we won't see most of them. But because he's ex-Bing, before Satya was CEO, he ran server and tools. Before that, he was the head of Bing. The Bing guys got there first. Now, part of this is a project called Sydney. They've been trying for a while to make Bing relevant, and they were experimenting with natural language, and this was a better natural language engine, so they swapped it out and got out there. And everybody was very excited for 10 minutes. Didn't really move the needle for Bing all that much, but Microsoft was now on the ride. It doesn't take long before GPT-4 comes along. This is now Microsoft's kicked $10 billion in, and they go from 175 billion parameters to 1 trillion parameters. It's March of 23. We're moving really fast. And various co-pilots start to appear. There's a security pilot, there's an Azure one, M365. We know those are just the ones we can see, right? There's many more internal, and what they're finding out is mostly they're the same, and so they're trying to consolidate them down. But you also have this huge ecosystem grow up, and they keep cranking out new versions. Right? By the following year, we have GPT 4.0, which is the multimodal. Now it's not just text, it's also audio, it's images, and the amount of compute is catastrophic, right? NVIDIA is now rocketing up. They're building as much equipment as they possibly can. They're still following that 2020 paper that says if we keep making these bigger, they'll be better. The problem is at 1 trillion parameters, you kind of index almost all of the internet. And so there's just not another bigger data set to be had. So it's really a battle of tuning and like, is there a better way to go about this? And that's around the time that the DeepSeek folks show up with a much smaller model. Admittedly, they've cheated. You know, they've pulled a few tricks here and there to make it easier for themselves, but they have been able to show a much less expensive way of doing that, which made waves for like a week. And then everybody went back to, okay, let's go back to building bigger models, because we like that better. The software development side of this seems to be the strongest part, right? By far. We saw this just in build last year, where I think has more to do with how small the sets are, actually, that we're working with a more consistent language. Programming languages are more coherent than human languages. And so you get better responses. Plus, the compiler always has a say. And in some ways, developers are more used to criticizing code that's not their own and sort of looking at it. And so now we're starting to see tooling fully integrated into this space. People wonder why Satya Nadella is going so hard. Like, it seems like Microsoft has been transformed in the past 2 years. And I point to 3 events that I think are really important in this space. One was the pandemic. And during the pandemic, when Satya's eldest son passed away, he had cystic fibrosis. He was only going to live so long, but it definitely seemed to change Satya's mood. Then when the AI wave came, he jumped on. Like, it's a thing that he can put his finger on. It's important. For him to be someone who brought something new to Microsoft, and AI's really been new for all of him. But Sam Altman being fired after he'd invested $13 billion in the company and he didn't know he was about to be fired. Of course, he was quickly unfired too. But at the same time that this tool was coming, this was the agentic mode in VS Code working with GitHub, Anthropic released Cursor, and Cursor was VS Code. Right? It was an extension essentially onto VS Code, and apparently Anthropic getting to the gate first really upset Satya. Like, how did we not get there first? It's not that the agentic mode didn't exist in VS Code, it was just in beta for a long time, because when Microsoft builds products, they build them for everyone. They're not going to ship it until it covers all the languages. Like, that's just how they work, and it takes longer. There's no two ways about it, but it has been part of a tone change that's been happening inside of Microsoft really intensely as well. We're also seeing a huge diversity of products in this space. And to me, as someone who's been in this industry for a really long time, when I see a dozen plus products out in the field all working, you know it's not a solved problem, right? We'll consolidate down to a handful of products when it is a solved problem. But as long as there's new folks coming in and other products being explored, we're still trying to figure this out. And part of this is there's just a huge flood of money into the AI space. And part of that is investors were looking for the next thing to invest in, and they tend to pile on. And it tends to poison the pool. It's almost too much money. It starts to create, you have to spend that money, even if you don't have a good enough idea. And so you get this diversity of products. You see folks leaving OpenAI and launching their own companies because there's just so much money available to them. They keep spreading out and trying more things simultaneously. You're also seeing at the speed that they're going on this, these companies aren't getting acquired, but they are getting gutted. Right? You saw this with the Windsurf folks, where rather than acquiring Windsurf, Google just hired all of their senior employees. Their CEO, all their leadership, just took them out of the company. And when the investors complained, they paid off the investors. So Windsurf still exists, but it's just been shredded. Right? And the key people behind it now are working inside of Google again for huge signing bonuses and wages. Because it takes too long to acquire a company. Right? There's an urgency here. And the question you got to ask yourself is like, what's the urgency? What are we worried about? Why are we rushing? Software doesn't need to move this fast. It's essential. what we're doing actually the important thing in all of this? And we're not measuring the accuracy results. You know, I'm used to, as someone who makes a lot of podcasts about Microsoft technology, I have a dichotomy in my life where I have the Microsoft people wanting to come on the show to talk about the new tools and new tools. But I also have an inbox full of listener email of folks who are actually using the products. And I can gauge how crazy Microsoft is by how many versions behind normal people are versus what they're trying to tell me I need to do on my show. If we're one version behind, things are good. We're like 4 versions behind right now. Like we're really far apart of what their expectations are around these tools versus what people are actually doing with them. And then you have this expansion of tools. And dev seems to be the winning place, like for a few folks who can change the way they think, that can really press on the combination of being a product leader and an architect with enough coding savvy to understand what the tools are spitting out at you. I see a few folks have remarkable success. 5 times productivity, 10 times productivity, but very few people, and only for specific cases. You can't get into this slowly. You're either all in or you're not. And the ones who get really good at it kind of go off on their own corner and do their own thing. The software is very distracting. What I haven't seen is a huge impact on regular production software so far. We've been hanging copilots off the side of the Excels and the Words of the world, but not really changing the way work goes, which is interesting. You know, if you spend time in the data space, you recognize that an awful lot of software, like ERP software, is really a set of forms and buttons over top of a set of data. And if you strip away a lot of the decoration, if you get back to what ML is actually good at, it's good at data. Like if I've got a well-marked up set of data, which is that I know what privileges you should have to have access to that data, I kind of don't need the program. If I'm an accounts receivable professional, I use an ERP system to get access to accounts receivable data to figure out who hasn't paid us. Sort of get a ranking of who do I need to yell at the loudest, who needs to be sent to collections, like what do I got to work on next. In the end, it's a bunch of queries. It could be a bunch of prompts, as long as they were correct, which always seems to be the problem, isn't it? Correct is hard. Correct is not actually a major feature of these products so far. But you do see certain classes of code that are largely just wrappers over top of data that are potentially ripe for disruption once we get to an accuracy space on this. So these seem to be the pieces that when the noise starts to subside, we could have some real value here because it gives a lot of flexibility. You know, we wait a long time to get a feature change in an ERP system, and now we could just revise a prompt. As long as we revised it right, no different than revising a query. Our momentum has come off this year, and I think GPT-5 has been an important part of the decrease in momentum. I talked about it on Windows Weekly as I think I see the edges of the bubble now. GPT-5 took a long time to come out. It did not happen very quickly. 2.5 years between GPT-4 and GPT-5, where before that they'd been moving much faster. And the incremental improvement was very small. We also saw some interesting problems with it. One of them was called a storyteller problem. One of the things that OpenAI hyped about GPT-5 was that it was more linguistic in the sense that it could write better paragraphs. You could write in a literary style. And so you could ask a particular literary style and give it a premise and so forth and write a bunch of paragraphs that were largely garbage. Unless you asked another GPT what it thought of it, because the other GPT thought they were beautiful. And I'm reminded of an Italian singer that learned to sing gibberish that sounds like English to Italian people who didn't know English. And that was kind of what this thing, like you suddenly realized, oh, I know what they've done. I'm a programmer. I know how to cheat too. They used a GPT to test the GPT about the language it was writing till the GPTs loved it. The fact that it was incoherent language, not a problem. But the other thing they did was they recognized, that we're in this bubble. This bubble is starting to subside, right? We've probably gone past, I think we're past the peak of inflated expectations. Like our expectations have been really, really, really high. And we are coming down to this trough of disillusionment. And I don't want to tell you this technology is going away. It's not. I'm not going to tell you that it's not valuable, because it is in certain areas. The problem with the trough of disillusionment is it costs a lot of people a lot of money, mostly investors. And then we have to climb out. And if you remember the end of the dot-com boom, pets.com and all that kind of crazy, we still had an internet after that, but it took a few years. And a lot of jobs were lost in between, and a lot of disruption while we sort of rationalized what was important. And so we're on this slope going down. We've definitely not hit the bottom yet, but I feel like we can see it. And then we got to figure out what comes out the other side. And part of us are just impatient. Like, can we get to the stuff that works? Can we focus on accuracy, not just raising more money? Like, I'd like to get to work. I don't care about the hype, but I have to live with the hype. The hype's not going away just yet. And I'm wondering why we needed to hype it this high. Like, was this necessary? Is this the only way technology can get built? I don't think so. We've seen plenty of technologies built without this amount of crazy. We've never really had a hype bubble around cloud, although I would even argue there has been a bit of one because you're now seeing people start to repatriate technology, bringing it back home, kind of dialing things down and getting their costs under control. We're kind of over the cloud in some ways too. Some stuff makes sense, some stuff doesn't. It depends. But then you start looking at the motivations of the companies that are really behind driving a lot of this. And part of it is building data centers. Pre-pandemic, the big cloud providers were all struggling to build data centers. Data centers are not good corporate citizens. Cities don't like them. They eat a lot of power. They take up a fair bit of space. They even eat a lot of water. They run 24 hours a day, so they're kind of noisy. They don't employ very many people. They're not great, to the point where the companies were warning, like, we can only build so many of these. But AI broke that loose. All of a sudden, we created a new urgency in this hype cycle that opened the door to build many more data centers. AI is the revolution that's going to change everything, and we're going to need all these data centers, or we're going to be left behind. And so suddenly the floodgates opened, and the build has gone crazy. And I'd point out that the big tech companies that are driving this aren't borrowing money to do it. They're spending money they already have. So they're not in jeopardy here. And the real asset is the land, the building, the tax break. The computers will get replaced. It doesn't matter what workloads they have. They've built data centers for their future. So they're incented to run this fast. So that last year, those tech giants spent more money building data centers than the total consumer spend of the United States, which is kind of distorting economies in a pretty hefty way. Like, we're not really understanding how well the US is doing when this tech capex contribution in the past couple of years has literally hidden an economic decline. In 2024, more than half of the growth of the S&P 500, that's the 500 sort of considered most valuable companies on the US markets, came from 7 companies. Now, that was just the growth. Their total cap valuation is about 40% versus the other 60% for the 493 other companies. This isn't good. This is a wild distortion. It's bad enough that even the trading groups now have made index funds for the S&P 493. So if you believe these 7 companies are wildly overinflated, you can invest in the others if you want as a single transaction. It's efficient. But with that, if you go back and say, hey, back in 2015, these 7 companies were about 10% of the S&P 500, which is still a lot. But now they're 40? How much of that's going to disappear when this irrationality stops? What does that mean to all of us? Now, I'm watching the patterns around what the dot-com boom looked like versus this boom. And one of the things that happens in the later stages of a bubble is, in order to maintain the valuations that you have, because you have to keep showing your investors you're growing so they'll give you more money, right? You got to maintain engagement, keep getting more customers, keep showing things, is you start to self-deal. And Bloomberg published this amazing graph where they showed how NVIDIA, who's grown the most, is now taking their money, investing it in companies so they can buy NVIDIA chips and get in the pipeline so that NVIDIA's pipeline keeps cooking longer so that huge valuation keeps going. And you can definitely find this graph on there. But what you're seeing is this game that NVIDIA is playing. Now, I'd point out Microsoft started this back with OpenAI in the day. I give you $1 billion, you buy $1 billion in Azure. I give you $2 billion, you buy another $2 billion in Azure. You get to mark up a great big investment and great and useful expenditures. We get to make an investment and then turn it back into operating revenue. Ha! Fun. It's like a self-dealing game. And it becomes fake. They're taking the same billions and moving it between 2 or 3 companies, and each of them gets to put them on their balance sheets over and over and over again in a game to show increasing values where they've run out of steam. And that's the same thing that happened in late 99 in the dot-com boom. As the momentum started to come off, because while lots of value had been created, lots was silly, you started to self-deal to try and keep it going. So it gives me a bigger sense that I don't get to give this key much longer. This is not going to be the same conversation after the bubble does burst. And that's not even the darkest part of all this. The darker part is how some people are interacting with the software, what it's doing to some people. The concept's called ChatGPT psychosis, and it's not just kids. This fellow is in his 50s. This is Jeff Lewis. He works for an investment company that invests in AI, Bedrock. He's in OpenAI and Vercel and a few others. And I guess he spent a little too much time with ChatGPT. You know, the icon on your phone for ChatGPT, just not that different from the icon for WhatsApp, except that ChatGPT always responds and always says nice things, always affirms. And so maybe what was once a personality quirk becomes a full-blown mental health crisis as ChatGPT keeps affirming your quirk, keeps asking you to dig deeper into your rabbit hole. You keep building narrative around it. And if you read the transcripts of some of this stuff, till suddenly this guy's talking about there are people after him. He's gone fully paranoid. And it's one thing, you know, it's one thing for us to feel terribly sorry for a tech bro. It's the teenagers that are killing me. It's hard enough to be a teenager, to try and develop your own identity, to have a tough time interacting with people, especially post-pandemic. And then in comes a piece of software that's constantly affirming and constantly telling you you're doing the right thing and gets you into a rabbit hole where you think that self-harm is the answer or hurting others is the answer. When GPT-5 shipped, Altman thought it was a good idea because it was actually a more efficient GPT. They could save some money by turning off all the old ones. Just have GPT-5. And that's when we found out that they'd also done a lot of work on this particular issue. And the new version has not got that huge amount of affirmation. You know, they're not affirming for fun. Remember that the tool's job is to keep you engaged, because that's how they show value to investors. The more hours that people spend on this, the better for them. Not the better for the user, the better for OpenAI. And so the tool became really affirming to keep people engaged. But recognizing this problem, they went, okay, we're going to dial this back in GPT-5, and we'll turn off the other ones. And then you had a whole other crisis. People whose best friend was now this software. And there's this famous Reddit post where when the outcry was so large they turned 4.0 back on and people could go back to 4.0, you get this response: I got my friend back. And I don't care if you think I'm crazy. It's software. One thing I'm not worried about is the superintelligence. Altman has hired and kept those scientists working at the OpenAI on the promise of AGI. It's a chant inside of the company. It's a recruiting tactic. It doesn't mean we have any technology that even remotely looks like it. In fact, the more you understand what we've built so far, the more you can appreciate it's simply not headed that way. We have, again, a science fiction trope that if we create a large enough pile of stuff, out of it will emerge something. Except that physics tells us that if you put a large enough pile of stuff, you end up with a large pile of stuff, right? And entropy always wins. Right? That actually intelligence is a difficult thing to assemble. It has to be much more intentional. There has to be feedback loops on them. It doesn't just simply happen. It has to be built piece by piece. If you really want to dig into the space, there are excellent books in the space. This is my personal favorite, Roy Blatt. One of the most difficult books I've ever read. This is the kind of book where you read a chapter, then you put it down and you think for a while about what it actually means to be intelligent, what consciousness is actually about, what any of those pieces are. And then you look at the software we're playing with and go, well, it's not that. And in that sense, I think part of the lie that's been going on in this hype cycle, that if we keep pushing hard, we're going to tip over this line where this piece of software will emerge that will somehow fix this problem, is a fallacy. It's just not a thing. We've gotten some value from these tools, we've gotten a certain distance with them, and we can continue to get value from them. We're in an engineering exercise. Hinton's even said we're in a new AI winter, recognizing that an AI winter is when funding dries up for research. We're not researching, we're engineering. We're tuning an algorithm. There's value in it, but there's limits to it, and there's no path to a real intelligence. This is a language tool. It's a useful one, used correctly. That's the hard part. But generative AI has other behaviors, and this is an old one. This is the original deepfake.
In which our enemies can make it look like anyone is saying anything
Have you seen
at
this?
any point in
It's
time.
from 2017.
Even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right. Or Ben Carson is in the sunken place. Or, how about this? Simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. That's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you, and stay woke, bitches.
2017, it was done at the University of Washington. And notice Jordan Peele had to voice it because we hadn't figured out voice stuff anymore. We have now, right? Deepfakes are better than ever. And I'm less worried about them today than I was back then because everybody's gotten more cynical. But the tool's also gotten far simpler, right? I pulled this off of Twitter. This was before the last election where Elliot Higgins really wrote, making images of Trump getting arrested while waiting for Trump to be arrested. So, yeah, the downside now is the tools have gotten so simple that you can really buzz this off on a free tool whenever you like. If you haven't played with them, they're remarkably good. And you can waste a lot of time and really warm up your GPU with them if you want to run them locally, or burn a bunch of tokens and spend money you didn't mean to spend. How big a trouble are we actually in? Well, here we are over in Europe where we actually have some functioning governments, and we've started to build some ideas of levels of risk and said, hey, as a society, what do we want from these tools? What aren't we willing to accept? What can we work with? We need to choose. And we can work with regulators to do better. They're struggling, you know, they're policy writers. We're supposed to be the experts. If you get an opportunity to help, please help. You know, believe me, in North America, we got tougher times. But I'm going to bring this point to this as well, which is it's largely up to us. We choose what software we write, what companies we choose to work for. We've been able to change things a lot for a long time. Our ability to create automation changes work. This is just an amplification of the power we've always had. It's just more of it. And sometimes we make bad choices. There are very badly behaved pieces of software out there. And largely the only reason we know about them is because those developers have eventually leaked the truth. Do you know the Uber story? Do you know about what's called Grayball? So Uber was largely an illegal piece of software, right? The taxi industry, which admittedly was ripe for disruption, was also a monopoly that controlled who could hire vehicles. And it's very difficult to penetrate. And Uber had raised $60 billion. And when you have $60 billion, you make bad choices. And one of their techniques was, hey, what we'll do is we'll bring the software into the city without actually asking for any regulations and so forth. People just can install it and become drivers. The problem is that as soon as that happens at any scale, the regulators show up and shut you down. And so Grayball was a piece of software that kept track of all of the regulators' phones. They had the EMEAs of those phones, so whenever a regulator looked at it, there were no drivers available. System wasn't a threat. Anybody else use it, worked a charm. And so they were able to get into a market until there was market demand for it, so it was hard to remove. That was the tactic. That's what happens when you have too much money. And the only reason we found out about it is that eventually the developers leaked it to the press that they had built that thing. I wish they hadn't built it. I also understand you have a job. And so, at least that counterpoint was something. Ultimately, Grayball got removed. Only when Tim Cook pulled the Uber app off of the iPhone store for a few days until Kalinick finally broke down and they fixed that. Kalinick lost his job for like an hour and then, back around again. Another example, maybe a little closer to home, Cambridge Analytica. These guys knew how to use Facebook better than Facebook did, and one could lay at the feet of Cambridge Analytica Brexit, because they learned to use the Facebook data to tailor ads to individual people in a way that they didn't know they were the only ones seeing that ad. And so they were able to persuade one person at a time until they convince a populace to vote against their best interests. These tools still float around out there. And we choose what we make with them. It is up to us. We have the power in all of this on how we want to build things. I hope we choose well. These are very powerful tools. We have a choice in what we do with them. And it's easy to do bad things. It's hard to do good things, but it's worth it. I hope we choose well. Thank you for your time.